Good morning, welcome to All Energy 2022 here with James Sturch, the Technical Director here for our region, and Brent Heber from New South Wales ACT. So we just wanted to talk through a couple of issues to do with our products, some fantastic issues with our products while we've got James here at the booth and the two of us together. In particular, on my system the other day, I saw my 10 kilowatt inverter producing 11.2 kilowatts of power. Now I've got a couple of batteries there, but my roof is not fantastic, and it's not a particularly fantastic site, but that amount of power coming off the system has, when I've shown it to a couple of Solar Edge salespeople, we've been a little bit baffled by, hang on, it's a 10 kilowatt inverter, what's going on here? So James, a bit of a technical explanation of what are we seeing here when we're getting these phenomenal outputs of our roof off a smaller inverter?
Sure, and I've seen the same on mine. I've got a 10 kilowatt single phase inverter as well, and sometimes I'm seeing 14, 15 kilowatts phenomenal production. But the interesting thing is, it isn't the inverter that's doing this. It's the production that you're seeing. You're not seeing the AC output from the inverter. And that's where people often get tripped up. They look at it and say, what is the inverter's production? It's not, it's the PV production. And we've got a DC coupled battery. So if you think we've got the ability to charge two batteries, 5 kilowatts each, so that's 10 kilowatt charge potential. Yep. You've got a 10 kilowatt inverter, which is a 10 kilowatt AC output potential. In theory, if you had the roof space, you could be producing 20 kilowatts, and it all could be being used and utilised. And that's the catch. So really, actually, it's just the way in which we are used to looking at monitoring, and the way that we've sort of been conditioned, is that you assume that production is the system production on the AC side, but it's not. We are looking at the DC production side from the panels.
Gotcha, because we have that utilisation benefit with a true DC coupled storage solution with the Solar Edge home battery.
Exactly. And also, because the battery and the panels are coupled before the input into the inverter, what we're seeing is the output from the optimizers. So we're not looking at a measurement taken from the DC input of the inverter, we're actually looking at the true rooftop production data.
Gotcha. So we've got that effortless flow of energy for full utilization of the DC. Now, the other part of the back of this is, again, with looking at individual panels, you've seen a couple of anomalies on your 370 watt smart panels as well.
Yes, absolutely. So again, it's interesting that when you couple on the smart panel, just a 370 watt panel with a 440 watt optimizer, the S440, you'd assume that a 370 watt panel can only give you 370 watts.
Makes sense.
Because how do we measure 370 watts? Where does that value come from?
Well, it's going to come from a combination of factors to do with air mass, the standard test conditions, the temperatures, and so forth and so on.
Yeah, 25 degrees cell temperature, air mass at 1.5, so basically 45 degrees, and 1,000 watts per square metre irradiance. So what I've seen on my system, and I've actually seen it on yours and some others as well, is you get this phenomenon where we can have temperature 20 degrees or less. We could still have the air mass at 1.5, so somewhere mid-morning, but our irradiance in Australia is way higher. That 1,000 watts per square metre is the global average. Australia isn't average, Australia is hot, you know. So if you're getting 12, 13, 1400 watts per square metre, which isn't unusual, we can actually see yield out of the module way high. I've seen it in excess of 410 watts on a 370 watt module. Yeah. And we can do that because we don't cap it in the same way that you would do with the string system. We can just basically go, give us everything you've got.
So this is in quite significant contrast to some other solutions where there's not only clipping on the inverter, but potentially clipping on the rooftop components as well.
Well, because the system has been designed around that STC value.
Yeah.
So all the input characteristics when you're doing your array design into the inverter is based on that STC value. So you then clip it to that STC value.
Amazing. Yeah. So what's the benefit then to homeowners of this architecture, the way that we can effortlessly flow and utilize DC from the roof into the storage or out to the grid?
It's really simple. From the rooftop perspective, we can generate more power. We can get far more yield from your PV system, and we've got a higher level of efficiency. Because the voltage of the battery is matched to the string voltage of the array, we don't have any conversion processes between the two. We can just take that power straight in and charge the battery, which is why we have the industry highest level of efficiency, branch of efficiency battery. So the customer gets higher yield and higher efficiency.
Fantastic. Thank you so much for your time this morning, James. Make sure you visit us at the All Energy booth here at All Energy 2022 to find out all about Solar Edge Home and the very exciting products that we've got coming out over the next 3 to 6 months.